Okay, so this is our next flipped lesson. This is looking at Unit 3, Lesson 8, and what we're looking at here is solids now. And as you can see, we have a Venn diagram once again. And whenever we have a Venn diagram, we're going to be looking at sorting, and sorting using some attributes. Okay, just like we did with the two-dimensional shapes last week. So up here in the corner as a reference, I have a square-based pyramid. Okay, so it's a square base and it's a pyramid because it comes to a vertex at the top, like a pyramid in Egypt, right? And the four characteristics of this shape here is we have a vertex, which is when any two lines come to a point. We have a face. In this case, there are four triangular faces, one in the front, side, this one here in the back, and then on the left-hand side. We have an edge, which is any line that makes this solid, and then of course we have the base, and the base is the side, the face that it sits on. Okay, so we're going to look at these and come up with an attribute for this Venn diagram here. And I think maybe on this side of the Venn diagram, what I'll do is it doesn't really, again, like we do with two-dimensional geometry, it doesn't matter what you choose, what attributes or what number you use, just as long as you have something kind of different. Okay. So I'm going to I'll say has triangle faces for this side. I'll move it over so we can see. Has triangle faces. And then maybe this side I'll write down, I'll sort it by has, let's say, 5 or more vertex. Okay? Remember what a vertex is. Just refer to the image here. The vertex is any edge that comes to a point. Okay, so if I look here, I have one vertex, 2, 3, 4. There's 5 altogether here. Okay, so let's take these shapes here and start sorting them around. If they don't fit in any of these, they go on the outside. If they both have triangles and has 5 or more vertex, they'll go in the middle. So here I have a cylinder. So look at the cylinder. This does not have any triangle faces. This does not have 5 or more vertex, so unfortunately does not fit in our Venn diagram. I'm going to slide it out. Here we have a cube. This cube does not have triangle faces, but let's see if it has 5 or more vertexes. I can see there's 1, 2, 3, 4, 5, 6, 7, 8. So clearly it has 5 or more that will fit right here. Here I have a prism. It's a triangular prism. It does have a triangle face. I can see one here. I can see one at the back. There's 2. So it could possibly go here. But let's see if it has 5 or more vertexes. It has 1, 2, 3, 4, 5, 6 vertexes. That's going to go in the middle because it has triangle faces and it has 5 or more vertexes. Okay, so here we have another prism. Okay, we have a pentagonal prism. We have a five-sided prism, and there are no triangles here. There's no triangular faces. I see a pentagon and a series of rectangles. Let's see if it has 5 or more vertexes. I'm just going to count the corners. 1, 2, 3, 4, 5. And at the back, 6, 7, 8, 9, 10. Of course it does. That slides over here. This is another pyramid. This is a triangular-based pyramid. Again, this is a square-based pyramid. So a square on the bottom. It's a triangle on the bottom, so a triangular-based pyramid. It does have triangles as a face. Let's see if it has 5 or more vertexes. 1, 2, 3. There's only 4 vertexes. That will go right here. It'll stand there. So look at this shape here. I have looks like a pentagonal pyramid. Pyramid because it goes up to 1 vertex at the point, like an Egyptian pyramid. It definitely does have triangle faces. I can see them all over. But let's see if it has 5 or more vertexes. 1, 2, 3, 4, 5, 6. It does have 5 or more. That will go in the middle. Here I have a rectangular prism. There are no triangular faces. I see some squares. Well, they're probably all rectangles here around. And let's see if it has 5 or more vertexes. 1, 2, 3, 4, 5, 6, 7, 8. Of course it does. Same as a cube. And here we have a square-based pyramid, exactly the same as this. It does have triangular faces. I can see very clear as a triangle here. But does it have 5 more vertexes? Let's count the points. 1, 2, 3, 4, 5. Yes, it does. And the last one, we have a cone. This is a cone. A cone has one point here, a vertex. It does not have a triangular face because it's kind of cylindrical, like a cylinder here, kind of going around. We would not call this a triangle because this is not a straight edge on the bottom. So it does not fit in any of these. It will go on the outside with the cylinder. Okay, so tomorrow's work, we're going to look at the solids that we've learned yesterday and the day before, and we're going to start sorting them into some attributes that you came up with, similar to last week's lesson dealing with the two-dimensional shape. So take some time, review this work, and have a great evening.